Hello and welcome you all to this lecture. Here we will be discussing about one important topic that is known as eigen value and eigen vectors. Okay. So here before going into this topic of eigen value and eigenvector, we need to know what actually matrix is. Okay, so in that case, see, all of you know the definition, basic definition of matrix. That is, matrix, it is nothing but a rectangular arrangement of some information. More precisely, these informations are nothing but numbers. Okay, in some cases you will get letters or symbols. Okay, so in general you can say it is a rectangular arrangement of some information. So when you are stating that rectangular arrangement, so immediately rows and columns will be there. So the general form of a matrix one can write like this: A is equals to A11, A12, A13, so on. Suppose A1n, A21, A22, A23, A2n, so on. AM1, AM2, AM3, so on, AMN. So this is a generalized form of a matrix. Okay, so here this matrix, it is of order m cross n. All right, now here this particular position, like 1 1 position, 1 2 position, 1 3 position, so these positions are important. Okay, so you should be aware about this representation, where you can write this as a ij, where I varies from 1 2 3 up to m, and j, it varies from 1 2 3 up to n. All right, now see, this is the generalized representation of a matrix, where you have these are known as rows and these are known as columns. Okay, so here how many column you are having? N number of column and m number of rows. Okay, so n number of columns and m number of rows you are having from this representation. So one simple example of this matrix one can have like this: A is equals to 1 2 1 2 3, suppose 0 0 5. Okay, so here 2 row and 3 column, so 2 cross 3 matrix. Similarly, suppose I am writing A is equals to, suppose 5 7 9 11. So this is a 2 cross 2 matrix. So this matrix, it is a proper rectangular matrix. This is known as square matrix. So these are all fundamental thing of matrix. Now few important terminology we should know before going into this eigenvalue and eigenvector topic. So first thing is few special type of matrices. Under this special type of matrices, but we have the first one. It is, suppose let A be a square matrix, then only we have the further discussion. Okay, so A, the first thing is A is equals to A transpose. If we are saying A is equals to A transpose, that means this matrix, that implies A is called symmetric matrix. Now A is equals to A transpose, then symmetric. A is equals to minus A transpose, then you have skew symmetric matrix. That is, A is skew symmetric matrix. So in this case, if A is symmetric, in that case what you have, Aij it is same as Aj for all I and j. Okay, this is the case. And here if you have A as skew symmetric, so in that case Aij it is minus Aji, so this is for all I comma j. Alright, next you should know that if I am writing m cross 1, a matrix of order m cross 1, this is nothing but a column matrix. And similarly, suppose 1 cross n, a matrix of order 1 cross n, this is row matrix. Now, what is diagonal matrix? Diagonal matrix, the basic form of diagonal matrix is this diagonal entry, this principal diagonal entries will be non-zero. Apart from that, you have all these entries as 0. So here 0, here 0, 0, 0, 0, 0, 0, 0, 0, 0. So here 4 cross 4 I am writing. So this principal diagonal entries, these are only non-zero entries. Okay, these entries. Apart from that, all the entries are 0. This is called diagonal matrix. Usually one use D to represent diagonal matrix. Now another thing is what? Upper triangular matrix. Upper triangular matrix. What is that? Upper triangular matrix. See, if you have this type of situation, that is, suppose I am writing 1 2 3, suppose 5 7 9. Okay, here 0 0 0, that means here below the principal diagonal, this is your principal diagonal entries. Below the principal diagonal, all the entries are 0. So you have upper triangular matrix. Similarly, lower triangular matrix. What is lower triangular matrix? See, 1 2 3, here all the entries are 0. Okay, here some entries can be available, but above the principal diagonal all the entries must be 0. So in that case you have lower triangular matrix. So these are few terminology you should be knowing before going into this eigenvalue or eigenvector discussion. Okay, because subsequently this term you will find. Now see another thing, that is, if you have a square matrix A, so if determinant of A is not equal to 0, then A is called non-singular matrix. Okay, not equals to 0, A is called non-singular matrix. So if it is non-singular or determinant is not equals to 0, so inverse also exists. Okay, so these are few terminology, already you know it from your 11th or 12th standard. Now it was just for your recall purpose. Now we are going into this main topic. So first thing, if you have a matrix A, square matrix A is a square matrix. Immediately corresponding to this A matrix, there is a linear transformation. So what is linear transformation? That you will see gradually, but for the time being, you take any square matrix you have, means immediately there is a corresponding linear transformation. So if you apply A on a vector x, okay, if you are applying A, that means a linear transformation on a vector x, then if you have, see, lambda into x, means that particular vector, either it get stressed or it get contracted with the factor lambda, For example, we can take one matrix and a vector, we will see it in the subsequent part. But now see, if A is a linear transformation, that means A is a square matrix, and in corresponding linear transformation, if you are applying on some vector x, then if the vector it is stressed or contracted with the factor lambda, then this lambda, it is known as eigenvalue of the matrix A, okay, and corresponding this vector, it is known as eigenvector corresponding to lambda, corresponding to that particular eigenvalue. So what actually it means? See, first thing you should know that Ax is equals to lambda x. This is the main equation where lambda is eigenvalue and x is eigenvector corresponding to lambda. So I can take one example so that this concept will get more clear to you. So for example, suppose let A is equal with 2 0 and 0 minus 1, suppose, okay, A is equal with 2 0 0 minus 1, and suppose x is equal with, suppose x1, okay, 1 0. Now A into x1, if you are doing, so what you have, see, 2 0 0 minus 1, and here you have 1 0. Now do the matrix algebra. Here multiplication will give you 2 0, here 1 0. So what you have, 2, here 2 0, here you have 0. So if you are doing this, you will be getting 2 times 1 0, which is nothing but 2 times x1. That means what you are having, Ax1 is equals to 2x1. That means this vector, if you just consider this, what was your earlier vector? 0 1 0 1. This was the vector, and once you apply that transformation, immediately this vector, it is stressed like this, okay, it is stressed like this, so with the factor 2. So here 2 is one eigenvalue for the matrix A, and this x1, what is this x1? X1 is this one, okay. This is called corresponding eigenvector for lambda equals to 2, okay. Similarly, see, if I take, suppose x2 is equal with 0 1, okay. If you do the multiplication again, Ax2, so here what is that matrix? 2 0 0 2 2 0 0 minus 1, and you have 0 1. So if you are doing this, you will be getting 0 minus 1, okay. So take minus 1 common here you have 0 1, so which is nothing but minus 1 times x2. So here immediately what you have, Ax2 is equals to minus 1 into x2. So this minus 1, it is another eigenvalue for this given matrix A, okay. So I think you got the idea that how we can determine eigenvalue, and there is corresponding eigenvector, okay. Now more precisely, we have this equation in our hand, which is known as characteristic equation. This is known as, so from here one can write Ax minus lambda x is equals to null vector. So from here A minus lambda times I, because it is matrix algebra, so x multiplied with null vector. So from here, see, for obviously for x not equals to 0, you are considering x not equals to 0 means x not equal to the null vector, okay. So if x equals to 0, so obviously it is a trivial case, we are not interested for the trivial case. So a minus lambda I into x equal with 0. As we are dealing with x not equal to null vector, so immediately what we have, a minus lambda I is equals to null vector. So from here, if you take the determinant here, so immediately a minus lambda I, it becomes 0. Okay, now just see, up to this it was a matrix equation. Now this equation, this last form, if you just consider this last form, this form, so this is nothing but a proper equation which involve lambda. Okay, so if you solve this equation, you'll be getting the value of lambda. So lambda value you'll be getting. Okay, so this equation it is known as characteristic equation. Okay, so characteristic equation, and this equation will give you the eigenvalues for given matrix. So for this matrix, what we just considered, that is 2 0 and 0 minus 1, if you take, so find eigenvalues of the matrix given by 2 0 0 minus 1. We consider this one. Now see, before going into this, one thing you should know, that a matrix A, it is, suppose 2 cross 2 matrix. Okay, the order it is 2 cross 2 matrix, so it should have 2 eigenvalues. Okay, if it is 3 cross 3 matrix, 3 eigenvalues. Okay, 4 cross 4, so 4 eigenvalues will be there. Now see this question, so a minus lambda I, first thing you need to determine, that is, say a minus lambda I, if you write it 0 minus 1 minus lambda times I means 1 0 0 1, here 2 cross 2 identity matrix. So further, if you do the calculation, 2 minus lambda 0 0 minus 1 minus lambda. See, one thing you can see, a minus lambda I, if you are writing diagonally, lambda will be subtracted. So here your equation is a minus lambda I determinant is equal with 0. So this is your characteristic equation. So from here, if you find the determinant of this matrix, it becomes 2 minus lambda minus 1 minus lambda is equal with 0. So from here, if you solve, lambda equals to 2 and minus 1 will be the eigenvalues. Okay, these are the eigenvalues, and just now we got this. See, this is one eigenvalue and this is another eigenvalue. So 2 cross 2 matrix, 2 eigenvalues are here. All right, fine. Now another question I can give. Find eigenvalues of the matrix A is equal with 2 minus 12 1 minus 5. Okay, let's try to solve this question. First work will be to find a minus lambda I. So here see, diagonally you need to subtract this, minus 12 1 minus 5 minus lambda. Now determinant a minus lambda I, you need to make it equal with 0. So what you have, determinant 2 minus lambda minus 12 1 minus 5 minus lambda is equal with 0. So if you further do the calculation, 2 minus lambda minus 5 minus lambda, here plus 12 is equal with 0. So if you further do the calculation, here you have lambda square, here you have, I think, lambda square. If you do the calculation, I think here you have minus plus 5, so plus 3 lambda, and here you have minus 10, here plus 12, so plus 2 is equals to 0. Now lambda plus 1, if you factorize this, lambda plus 2, so lambda is equal with minus 1 minus 2. This will be the eigenvalues. Okay, this will be the eigenvalues. Fine. Now see, it is 2 cross 2 matrix, so immediately can have this treatment. This is by applying, this is known as characteristic equation. Characteristic equation, you can get it. Okay. So these are the eigenvalues. Now see, few important properties, or there are few shortcuts you can say for to determine eigenvalues here. Suppose for here under the note you can write, suppose let A is equal with A11, A12, A21, A22. Okay, so in that case the characteristic equation, it is given by, see already you know that is given by A minus lambda I is equals to 0, and from there you will be getting equation of lambda. Okay, so immediately if you want to write this characteristic equation, this is given by lambda square minus here you can write S1 lambda plus S2 is equal with 0, where this S1 and S2, you should know what is this S1 and S2. S1 is sum of the principal diagonal entries, that means A11 plus A22. Okay, and S2 is what? Determinant of this A, Okay, so this thing you should keep in mind. If it is 2 cross 2 matrix, directly you can do, that means sum of the principal diagonal entries into lambda, here obviously lambda square minus S1, that means sum of the principal diagonal entries into lambda plus determinant. If the matrix it is of the form, suppose A is equal with A11, A12, A13, A21, A22, A23, A31, A32, A33. So in that case, the characteristic equation, obviously A minus lambda equals to 0, determinant you can do, and after that you can do the calculation. Obviously that is the usual process, and for shortcut purpose the characteristic equation it is given by lambda cube minus S1 lambda square plus S2 lambda minus S3 is equal with 0. So here S1, what is this S1? S1 is A11 plus A22 plus A33, that means sum of the principal diagonal entries. S2 it is given by sum of the minors of leading diagonal elements, so sum of the minors. So if you consider this one, this element, this particular element, suppose A11 we are interested in, so the minor will be this part, minor. Okay, this is corresponding to the first element. So what you have, A22, A23, A32, A33 plus, if you consider this second element, see this element, so corresponding minor is what? See this entry, this one and this one. So what you have, see A11, A13, A31, A33 plus, if you consider this element, what will be the minor? This part will be the minor, this part. So you can write this, that is A11, A12, A21, A22. Okay, so that is S2. And what about this S3? S3 is nothing but determinant of this given matrix A. Okay, so if it is 3 cross 3, so you can take this treatment, that means just find the principal diagonal sum that means S2 is given by the principal diagonals corresponding minor, add them, and S3 is given by the determinant. So these are two shortcut technique by which one can immediately find characteristic equation and get the value for eigenvalues. Okay, now say find characteristic equation of the matrix. Write down this question. Find characteristic equation of the matrix (0, -2, -2, -1, 1, 2, -1, -1, 2). Find characteristic equation of the matrix and determine eigenvalues. Okay, so let's try to solve this question. So solution, if suppose this matrix it is A, so one way A minus lambda I is equals to 0, find determinant and find out the value for lambda by making it equal with 0. This is one way. Another way is what? Just now we learned this technique. So first we'll find S1. First, what is S1? S1 is 0, 1 and 2, that is 3. S2 is what? S2 is first this part 1, 2, -1, 2 plus next part 0, -2, -1, 2, 0, -2, -1 and 2 plus next this part you need to take 0, -2, -1 and 1. These are the minors. So if you find it, the first part will give you 2 and here you have 4. Here you have again -2. Here again -2. So it is 0. So S3, if you find the determinant for the entire matrix with respect to this, suppose you are finding this determinant 0, -2, -2, -1, 1 and 2, -1, -1 and 2. So if you find the determinant, it would be -4. So immediately the characteristic equation it is given by lambda cube minus, here you have S1 value 3, lambda square, here 0, 0 lambda, here minus of -4, that is equal with 0. So lambda cube minus 3 lambda square plus 4 is equal to 0. If you solve this equation, immediately you will get lambda value. These are the eigenvalues for the given matrix A. Okay, so think this is the process for eigenvalues. Now we'll go to the eigenvector part. Okay, we'll try to determine eigenvector for the respective eigenvalues. So one question we can take now. Here write down this question. Find eigenvalues and corresponding eigenvector for A is equal with 2, -12, 1 and -5. Now before going into this part, one thing you should know, that suppose this is a 2 cross 2 matrix, so that is guaranteed that there are two eigenvalues, lambda 1 and lambda 2. Okay, two eigenvalues. So corresponding to each eigenvalue, see lambda 1 we can find, suppose v1, corresponding to lambda 2 we can find v2. Okay, see this v1 we can find. Now any scalar multiple c into v1, this is another eigenvector. okay, corresponding to lambda 1. Similarly, suppose k into v2, it is another eigenvector corresponding to lambda 2. That means what we are saying, that c and k, obviously these are some scalar numbers, scalar numbers. Obviously these are non-zero, first thing. See, so corresponding to each eigen value, there can be infinitely many eigenvectors, okay, and corresponding to, say, each eigenvalue, there are infinitely many eigenvectors. And see here, this v1 and v2, these two vectors, see, v1 and v2, this must be linearly independent, okay, linearly independent. See, you can consider few questions and immediately you will get the idea. For that we are having this problem, so we'll try to find first eigenvalue a minus lambda I is equals to 0. You can set this one, or you can use that shortcut technique, and from here you will be getting lambda square minus sum of the diagonal entry, that is what you have, see, plus 3 lambda, and then you have the determinant, that is that 2. So from here lambda plus 1, lambda plus 2 is equals to 0. So the values are lambda equals to minus 1 and minus 2. These are the eigenvalues, okay. So see the process for lambda equals to minus 1. See, our main equation was ax equals to lambda x, okay, ax equals to lambda x. This was the main equation, so we'll take help of this equation. So from here what we have, a minus lambda I into x is equals to null vector. We'll take help of this main equation. So as per this equation, you should have a minus of minus, let me write this one properly. So you have x equals to null vector. So what you have, a plus I, x equals to null vector. So here a plus I, a, what is a is 2, and plus I means diagonally 1 will be added. So what you have, minus 12, here 1, minus 5 plus 1, here x means x1 x2, so here 0 0 0. So if you do the further calculation, 3 minus 12, 1 minus 4, here you have x1 x2, so 0 0. Now see, 3x1 minus 12x2, here you have x1 minus 4x2, so 0 0. Compare this, so you will be getting 3x1 minus 12x2 is equals to 0. Here x1 minus 4x2 is equals to 0. So together you have x1 minus 4x2 is equals to 0, which is nothing but x1 is equals to 4x2. Alright, so here what you have, let x2 is equals to, suppose I am writing c, so x1 will be 4c, okay. So what you have, see, so x is equals to, you know, x1 and x2, so x1 means 4c, here x2 means c, so this is nothing but c common, so 4 1. So here immediately you can see x is equals to c times 4 1. Obviously c cannot be equal with 0. If c is 0, so what you have, x equals to 0 0, which you cannot accept, because by definition here x is non-zero, because if x is 0, then this is the case of trivial situation. So we are not interested for trivial case. Now see what you have, this is eigen vector corresponding to lambda equals to what, lambda equals to minus 1, So now if you want one eigenvector, so immediately you can write 4 1. Suppose v1 it is 4 1, okay. If you want more eigenvector, so it is nothing but a multiple of this vector only, okay. So this is one eigenvector corresponding to lambda equals to minus 1. Similarly for lambda is equals to minus 2, if you want this, so immediately see what you had, a minus of minus lambda, a plus 2x equals to null. So a what you had, a is equal with 2 plus 2 minus 12, 1 minus 5 plus 2. So here you have x1 x2, so here 0 0. If you do the further calculation, you will be getting here 4 minus 12, 1 minus 3, x1 and x2 0 0. So further if you do 4 x1 minus 12 x2 is equals to 0. Here x1 minus 3 x2 0. So both implies x1 minus, it is 3 x2. Alright, so let x2 is equals to k, so x1 will be 3k. So immediately just by that previous treatment, same thing, that means x is equals to x1 3k, here you have k, so k common, so 3 1, obviously k not equals to 0. So you can write that v2 is equals to 3 1. This is one eigen vector corresponding to lambda equals to minus 2. Now observe one thing carefully for these two eigenvectors. If you take this v1 and this v2, okay, this v1 and v2, they are linearly independent. This is one of the key results from this understanding. See, these two eigenvectors are linearly independent. How will check linearly independency? So for that, c1 and c2, see, c1 v1 plus c2 v2 is equals to 0. If you set this one equal with 0 and then do the calculation, for the calculation you will find c1 equal to c2 equal with 0. Okay, this is one way. Or another way is what? You can simply find the determinant, that is 4 1 3 1. You will get not equal to 0. So these two eigenvectors are linearly independent as well. Okay, so for the time being, what we understood from today's discussion, that what is the basic idea of eigenvalue, okay, what is the basic idea of eigenvalue, and what is the geometrical interpretation. Actually either this lambda times, when you are writing lambda times, means either it will, this particular vector get stressed or it will get contracted. Okay, and here we had the characteristic equation. Okay, characteristic equation means it will determine the eigenvalues, and corresponding to each eigenvalue there can be infinitely many eigenvectors. Okay, and we saw the process by which one can find the eigenvalue and the eigenvector, and in between we had this shortcut technique under this note, where this shortcut technique. In the subsequent class we'll see further discussion and few important properties of eigenvalue and eigenvector as well. Okay.